Hello again. Okay, I figured it out. Um, Basically, there's a fun little option here. So normally you can't really see what you are. There's a fun little option here under display called enable, or rather show cursor coordinates, and then it'll show you the coordinate of the point you're looking at. So we go ahead. You want to read this as x and y, so we go ahead. We're a little bit towards the left. That's the x, and we head straight up. Right about here, which looks like our odometer was accurate, right about here is our origin. Right about there. Wonderful, great. So here's the origin. But let's say for the sake, let me double check my recording. All right, great. Let's say for the sake of the argument, we wanted to move the origin. Let's say rather than getting the coordinates of all the cubes relative to this point, let's say we wanted to get the position of all cubes relative to, let's say we wanted the position of all cubes relative to this briefcase. This looks like the radio's briefcase, I want to say. So let's say we wanted to get all the positions of the cubes relative to the center of this briefcase. Now, there's two things we have to accomplish in order to do this. The first is translate the XY of the map and also change the rotation. So, like for example, we look here, right? This is the map from ARC 2025. The arena had this sort of axis, and you had to get the positions of the cubes relative to this coordinate system. Now, if you'll notice here, if you look here in the bottom, I'll go ahead and zoom out. Maybe I'll zoom in to make this a bit more visible. If you look in the bottom right, we have the axes of cloud view. This shows us what the points are being measured relative to. Now, let's assume for a second that our map, this suitcase, is equivalent to this source coordinate frame that the judges have defined for us. If we see here right now, not only is this not the origin point in terms of x and y, this is also not the origin point in terms of the rotation. We need this briefcase we need this whole point cloud to be rotated until this axis in the bottom right matches up with this axis here. So this whole point cloud needs to be rotated clockwise, 90 degrees, right? Because if this is meant to be our x and this is meant to be our y right now, this x is our y, and this y is our x. We have to go ahead and rotate it. So I would recommend rotating it first, because if you update the translation of the map and then rotate it, the translation of it will change. I think. Either way, it's just a bit easier. I think it's safer to rotate it first, honestly. So let's go ahead and do that. The way I like to do it is just go ahead and, first of all, make sure you select the map, and then go ahead and enter translate and rotate. And we just want to make sure that we're only rotating around the Z axis. We don't want to mess with the X or the Y. So let's go ahead and do that. Let's hit the top view. Let's zoom out. You want to zoom out until you see the box containing the point cloud. Not necessarily, but it just makes it a bit easier because you see it rotates around the origin of this box. So if you zoom in and you try to rotate, it's going to be a bit difficult. A bit more difficult. Not impossible, but just a bit more difficult to rotate it. So if we go ahead, you want to rotate it. So, am I rotating? I think I'm rotating this the wrong way. Yes, we want it so our x-axis comes out of here, and our let me double check that map. Yeah, so our x-axis is pointing this way, and our y-axis is pointing that way. So we have to rotate this 90 degrees clockwise. So zoom out. Go ahead and do that here. Great, that's what we want. Now, in order to actually make this a bit more accurate, what I'd recommend is finding a nice long flat face that is going to be parallel to your axes. So for ARC, this will probably, hopefully you'll be lucky enough to actually see this marker in the map. So ARC 2025, there was a physical marker present in the map at this location that you could, in theory, use to line up your orientation. If not, you can also just use the walls of the arena. So you can see here this x-axis arrow, it also lines up with the wall of the arena. So you can also use that as well. In our case, rather than using the briefcase, I could use the briefcase. I could line up the sort of parallel side with the y-axis. I can also line it up with the wall of this car park, which I'm going to go ahead and do. So if we try, I'll use this wall here. This will be nice and easy. Go ahead and zoom in a bit, and if I just, we want to be a bit zoomed out so we can see any slight changes. Let's just go ahead and, yeah, that looks pretty straight. Yep, cool. Go ahead and save that. Great. Now our map is rotated like this. Our x-axis is coming out of there. Our y-axis is coming out of there, and that's matching up sort of how we want it to look here. Wonderful. Okay. Next point is the translation component. So you can either go ahead and select the point picker here. You can also go ahead and just shift and left click, and now go ahead and just create the point. So if we do that, actually let's go ahead and pick right in the middle of this briefcase. Now, when you zoom in, you'll see that obviously the points spread out a lot, so it gets a lot harder to see what you're looking at as you zoom in. There's a really nice shortcut. If you just move your mouse to the top left, this little menu will pop up, and you can go ahead and increase the size of the points. Makes it a lot easier to see what you're looking at as you zoom in. Obviously, I don't recommend it increasing the point size as you zoom out, because then you lose a lot of detail on sort of what's actually going on. So I recommend just like increase the point size and decrease the point size as you zoom in and out. But for now, we're just going to go ahead and zoom in. This briefcase here. We're going to go ahead and select the point sort of right in the middle there. Great. So that is now our origin. The orientation is correct, but the translation is not correct. So we're going to go ahead and copy that value. So you just want to make this point, select the point, click this whole box. It's probably, I think this is the quickest way I found to do it. Just select this whole box, Control C, go into a text editor, Control V, and now it's these two values you really want. This is the X and Y translation. You can ignore the Z because the judges want the X and Y coordinates of the cubes, not the Z axis. So go ahead and select the map again. We want to go ahead and apply transformation this time, and we want to go ahead and just straight up copy these values. So that's the X translation. That's going to be the Y. And then make sure you're applying the inverse transform. So we go ahead and click OK. And now we can see this point here still facing the right way. Go ahead and decrease the point size. It's still facing the right way, and now it is at 0, 0. So if we go ahead, and I'll go ahead and actually unselect this. If we go ahead and click the coordinates of any cubes, we're going to go ahead and get the right values for them. So that brings us to the final point. How do we actually go about finding these cubes? Okay, let me go into like something isometric. There we go. Whoa. Okay. So as you might have guessed, this is going to involve the scalar field. This is the best tool we have to sort of emphasize the positions of these cubes. So go ahead. And we're looking for anything cuboid. That's a bit too much. Okay, so I can kind of see. I wasn't here when this map was taken, so I actually don't know where the cubes are. I'm basing it off entirely where I think I can see the map. Let me go ahead and increase the point size. Okay, so I can definitely see there's clearly one here, here, and here. So let's go ahead and zoom in on these points. Go ahead and do top-down view. Yeah, that's clearly a cube. You can see the faces here. So go ahead and I'll shift-click there. So that's one cube. Is that another one here? No, that's too tall to be a cube. Oh, there's a cube by this pillar here. I can see that. So let's go ahead and zoom in. Another cube. At that point, it might actually hide these just so they're not cluttering up my screen. So we got that one. This is the one I got before, right? Yep. Is this one right here? I can see this. Yeah, look at that cube looking. Yeah, that's a cube. Boom. That's 3. That's 30 points right there. Oh my god, I can't see anything. Okay. Where is that last one? There's meant to be 4. Oh, wait. I think I see it. Oh, here we go. I've lost it. Oh, there it is. Okay, wonderful. So you guys are going to have to do this in comp a lot faster than I'm doing it right now. You guys are going to have to practice this. Yes, increase that point size. Now you can clearly see here's 1 point. Actually, maybe if I bring this scalar field down, there you go. You can see that a lot clearer now. Yeah. So go ahead and shift click sort of in the middle of here. Wonderful. Okay. And now if I zoom out, click that top view. There's our origin here, and then we've got 1 cube. That's not what I wanted. We've got 1 cube here. I want to go ahead and decrease the point size. This is a bit easier to look at. Okay, wonderful. So we've got 1 cube there. We've got 1 cube here, and we've got 1 cube over here. Great. And as you can see, all of this is relative to our coordinate system. So if we look, this cube here, it's more or less the same x-axis, but it's increased about 4 meters away in the y-axis. This one's the other side around. It's 4 meters away in the x-axis, but it's only about a meter away in the y-axis. Same deal here, same deal here. And what you'll have to do in comp is just go ahead and copy these 4 values onto a little sheet of paper that the judge is going to give you. And you'll have to write down the color of the cubes. Now, unfortunately, this is not a colored map. This is just normal, like, uncolored point cloud. So you're not going to be able to tell the colors of the cubes based just of this. Hopefully, in comp, you guys will have a colored point cloud to look at, in which case you would just zoom in on every cube, and then right under here, under colors, there would be an RGB option that you could select that would then change it from using the scalar field to color the point cloud to using the RGB values. If you don't have that, you would just have to rely on knowing where the general position of every colored cube is based on what you saw through the camera feed. That's it.